In this demonstration, I'm going to find the intersection point between a circle and a parabola, and I will write the program in Python in an inspective way of getting to the results. So for simplicity and to make it conform with the vectorized structure, I write the equations in this format. X1 equals x2 squared by 4, which is the equation of parabola, where x1 is separated and x2 is evaluated from the equation of circle. So here I have ideally Python. So I first import numpy as np, and I define a function g of x, right? And I define a value vector, the values to be stored in a vector. So, okay, I can define x new. X new is equal to numpy array, numpy, okay, zeros. And this should have the similar size as the size of the x, numpy size of x. And the data type should be of float. So this is the definition. Okay. Well, this parenthesis is extra. Okay. Maybe Python is okay with that one. Oh, no. Okay. And now x new of 0, because our indices are 0 and 1. So it should be x squared by 4. Yes, x2 squared by 4. So it will be x1 and square by 4, and x new of 1 will be equal to numpy square root of 1 minus x 0 and square of it, and therefore x 0. That's it, and the function should return x new vector, and that's it. Okay, so if I calculate g of x, if I define x equal to numpy array 0, 0, and then I calculate g of x. So this is fine, right? With the 0 value, 0, 0 value, we have the answers 0 and 1, right? We have seen that one in earlier demonstration that this was true. Now the algorithm is simple. Start with the initial guess, calculate the function vector, right? New vector, and then replace with the old guess. So I can write like I wrote in the earlier algorithm of single variable. So I define y equal to g of x. Let's again start with the initial approximation 0, 0. X is 0, 0, right? Then define y now as a vector, g of x, right? Y is 0, 1. Then I can set x equal to y, right? Exactly on similar lines. X is equal to y, and then y is equal to g of x. Y value has again been changed, right? Right? G of x equal to y, and then y is equal to x, right? And this is going to be valid, this structure is going to be valid irrespective of the number of equations you have, right? So very handy thing. However, there is the inbuilt limitation that the algorithm will find convergence only if the partial derivatives of g functions with all the variables should be less than 1. You can do it even much faster way. So the step of defining y can be eliminated. I can say this is equal to g of x. But you have to have an error estimate. So error is should be calculated with the second order norm, which is like the distance formula. So numpy linear algebra dot norm. I hope I have written that correctly. Minus x. Okay. So correct. Error is 0.25. Now again, write the expression for y. No. Since y was calculated, I have to now calculate the x. X equal to y. Then calculate g of x. Then calculate the error. Print the error. Right? Let's perform another calculation. Set x equal to y. Then set y equal to g of x. Then set the error calculation. See the error. You can program in Python to look for the errors and then decide whether to perform a new iteration or to stop at this point. So we can witness that the error is decreasing. Let me do some calculation in a quick way. Right? X is equal to y, and then I say x is equal to g of x. Then again I write x equal to g of x. Then again write x equal to g of x. Then again write x equal to g of x. Then write y equal to g of x. Okay. And then calculate the error. I have performed additional 1, 2, 3, 4, 5 iterations, right? 5 iterations. And then let's calculate the error. And now the culmination error. Behold, this is an historical moment. The error has reduced to 10 raised to the power minus 5, right? And you can see I have written only 3 or 4 lines of the programming. 3 or 4 lines of the programming. That is the way of doing programming in inspective way, right? Running the program for step by step. So you can see all the steps written here in this demonstration. Okay. With this success of the program, we can stop at this point. That's the right way to stop the recording.